Hi everyone, this is an introduction to systems thinking. We'll dive into some definitions of systems and systems thinking and highlight the importance of understanding these concepts for solving complex problems. Then we'll introduce some key principles, and after that you can practice with some of these concepts in order to enhance your understanding. So before we start, what is a system? I like this definition right here. A system is an entity which maintains its existence through the mutual interaction of its parts. A classic example used when describing systems is that of a car. The goal of that system is transportation, but it's comprised of many different parts, like the tires, the steering wheel, seats, the motor. But none of those parts can take you from point A to point B by itself, even the motor. Which leads us to what is system thinking. It's the process of understanding how parts influence one another within a whole, revealing connections and effects across the system. Taking the previous example of the car, systems thinking would be the process of understanding how each part of the car influences other parts. For a fuel-based car, the gas pedal acts as an interface between the driver's intention and the car's mechanical systems. Pushing the pedal mechanically increases the flow of fuel into the engine, and that increased fuel mixed with air is combusted in the engine, creating the energy needed to move the car. That energy created in the engine is then transferred to the wheels. So this is just an oversimplification of what's actually going on when we push on the gas pedal, but hopefully it gives an idea of what this process of systems thinking looks like. So why do I think systems thinking is important? I think it helps us identify deeper insights and holistic solutions in complex situations. It increases our adaptability, where in a rapidly changing world, systems thinking helps us adapt by understanding dynamic environments, predicting future trends, and preparing for potential impacts, making it easier to navigate complexity and uncertainty. It improves decision making. By understanding the complex web of interactions within a system, individuals can anticipate the broader consequences of these actions. And by anticipating these trade-offs, we can minimize their severity or even use them to our advantage. So systems thinking therefore allows us to make more informed and strategic decisions. And then it enhances problem solving. It equips us with the ability to identify and address root causes instead of just treating the symptoms, and this can lead to sustainable and effective solutions. So these are some of the key principles that I think are important for systems thinking. Holism suggests that systems cannot be fully understood just by analyzing their parts in isolation, because the system as a whole determines how the parts behave. If we take an example of a sports team, the team's success isn't just about the individual players' skills, but how they play together, creating outcomes that individual excellence alone could not achieve. Interconnectedness is a principle that emphasizes that all the parts of the system are connected, and changes in one area can influence the entire system. For example, in an ecosystem, the removal of a single species can have cascading effects to the food chain and the plant life, altering the whole environment. Feedback loops describe how systems self-regulate through cycles of output affecting future operations. A thermostat, for example, uses negative feedback to maintain a room's temperature. If it's too cold, the heat turns on until the temperature set is reached, and then it turns off, continuously adjusting to maintain equilibrium. Causality is a principle that looks at the relationship between causes and effect they produce. Understanding causality helps us identify why things happen. For instance, poor nutrition, which would be the cause, could lead to health issues, which is the effect, showing that there's a direct link between diet and well-being. Emergence refers to properties or behaviors that emerge at the whole system level from the interactions of the system's parts that cannot be predicted from the properties of the parts themselves. For example, consciousness is not a property of individual neurons, but emerges from the complex interactions within networks of billions of neurons. And then leverage points identify areas within a system where minimal inputs can lead to significant and broad-reaching changes. An example is an organizational change, where altering the company's culture can transform employee engagement, productivity, and innovation, showcasing that targeted adjustments can catalyze comprehensive shifts across the organization. So now it's time for you to practice. Identify systems in your life. Think of any system that you interact with frequently. It could be a bicycle, car, a computer, or even a community, school, your own company. And try to think, what are the main parts? How do they interact? And then share your analysis with others and explain how a change in one part of your chosen system could affect the whole system. So this practice and thinking of how systems around you work will deepen your understanding and systems thinking. Thank you for listening.